The Raider Outboard name was selected to recognize the World War II Marine Corps raiders who used inflatable boats for reconnaissance and clandestine entries. Even from under the cover of night, the raiders deployed from submarines and paddled ashore. No military unit in the history of the United States brought more honor and glory to themselves, more pride to their countrymen, and more grief to their enemies as the United States Marine Raiders. The new Raider Outboard has been specifically modified for difficult clandestine operations and search and rescue missions. Today's Navy SEALs use several methods of deployment for missions, including helicopters, submarines, and airdrops. These missions require sturdy, inflatable watercraft and reliable outboard motors. Currently, the improved Marine Amphibious Reconnaissance System outboard motor is used on these missions. This modified commercial off-the-shelf motor is a two-cylinder, two-stroke outboard developed in the late 1980s and operates strictly on gasoline. New outboard motor technology, along with a multi-fuel requirement mandate from the United States government, is retiring the IMARS and necessitating a replacement with a new multi-fuel submersible outboard motor. The Naval Surface Warfare Center, located in Panama City, Florida, was tasked with reviewing current outboards to recommend the next generation of outboard motors to the Department of Defense. As part of NSWC's review, an airdrop exercise was held to observe issues with the current IMARS with potential fixes that should be included in the next generation of outboard motors. The biggest problem observed from the exercise was the inability of IMARS to start in a reasonable amount of time, with the process taking in excess of 20 minutes. There was also a safety issue during the pull start procedure that will be addressed. Sometimes, 2 IMARS are sent on critical missions to ensure that one successfully starts. NSWC analyzed the IMARS dewatering system in detail to investigate what could be done to achieve quicker starts. The most significant issue was water getting trapped between the pistons and the head, causing hydrolock. IMARS does not have a dewatering valve in the powerhead to minimize the hydrolock and requires the water be eliminated by the soldier's continued pulling of the starter rope until the cylinder head is cleared. NSWC began an internal program in 2009 to modify 4 commercial off-the-shelf 30-horsepower Evinrude E-Tech outboards as a replacement for IMARS that would operate on multi-fuels and be submersible. Robotics and Conceptual Engineering supported NSWC on this project through a series of contracts and providing test equipment, engines, and support functions. NSWC tested the Evinrude 55 multi-fuel engine outboard used by the Marines. The operator flips a toggle switch between light and heavy fuels. This outboard has a dewatering system, but still requires between 10 and 20 pulls to start after the dewatering process has been completed. And while not rated as submersible, the MFE will, however, withstand a shallow water immersion for a limited time. Issues have surfaced with the 55 MFE, including premature corrosion, exterior cracks, and breaking of the external structure and mechanical items. After 5 submersions, the MFE has to be torn down and parts replaced due to corrosion. Both the IMARS and the 55 MFE are Evinrude products. When Evinrude went bankrupt in 2001, they were purchased by Bombardier Recreational Products, located in Montreal, Canada. BRP chose not to continue supporting the IMARS as a product. This action, combined with the Department of Defense directive that mandated elimination of gasoline on any new outboards due to the volatility issues, set the stage for NSWC to embark on a replacement program for the IMARS beginning in 2009 and set to be completed in 2012. NSWC selected the Evinrude 30 as their baseline outboard as it was the closest commercial off-the-shelf engine to the IMARS. It fit all the physical parameters and appeared to be an adequate replacement for the IMARS. The 55 MFE was considered too heavy and too large for the smaller combat rubber raiding crafts and was not fully submersible. In March 2011, Robotics and Conceptual Engineering was awarded a full and open contract by the United States Special Operations Command, Tampa, Florida, to deliver 4 submersible, multi-fuel engines for the combat rubber raiding craft. This award was based upon our previous work with the IMARS 55 MFE and the NSWC modified Evinrude 30. NSWC supported this contract with a loan of a government-furbished combat rubber raiding craft and engineering support. The non-gasoline burning outboard engine contract award called for the delivery of 4 next-generation, multi-fuel, submersible, airdroppable, quiet, efficient outboard engines to propel the combat rubber raiding craft. The contract was administered by the Naval Surface Warfare Center, or NSWC. Under this contract, Robotics and Conceptual Engineering reviewed 3 potential options and implemented 2 options under the contract. Option 1 was the continuation of the work by NSWC modifying the 30 Evinrude E-Tech. As part of Option 1, Robotics and Conceptual Engineering purchased an IMARS for evaluation purposes. Concerns over patents and data rights led to rejection of Option 1. Option 2 was development of an outboard engine based upon a clean sheet of paper. This option provided the government all rights to drawings, hardware, and software, which eliminated future data rights concerns. NSWC supported this option as they could control all future modifications to the outboards. However, the available time and resources were insufficient for the development of a complete, mature, production-ready multi-fuel outboard engine as a new start development. Under Option 2, Ricardo Incorporated was awarded a contract to modify an existing 2-stroke multi-fuel single-cylinder 17.5 horsepower engine developed for the Shadow unmanned aerial vehicle. The new motor, based on this design, would be a twin-cylinder 2-stroke outboard developing 35 horsepower. NSWC supported this option with engineering and GFE of a combat rubber raiding craft. The Ricardo contract was for inline twin cylinders, multi-fuel submersible powerhead that developed 35 horsepower at the shaft. The consensus was this motor would provide more horsepower than the IMARS and correct known deficiencies. During this contract, monthly meetings were held by Robotics and Conceptual Engineering with Ricardo, NSWC, SEALs, and subcontractors in attendance. The meetings had knowledgeable experts from NSWC and the SEALs that resulted in a design of sturdy carrying handles and a rugged composite single-piece cowling that would withstand missions and be easy to remove. The technical issues focused on were dewatering, anti-corrosion coatings, silencing options, and human factor considerations. These meetings were significant in the designing of a completely new dewatering system, eliminating hydrolock issues. As a result of the SEAL's input, a lightweight transom mount that holds the motor to the combat rubber raiding craft was developed. This rugged transom mount was designed for quick installation, even in high sea conditions. A new tiller handle was designed to fold into the cowling for easy passage through submarine hatches to protect against damage, and still be rugged enough to lift the outboard up by the tiller handle. The tiller design also allows for a single control adapter to be utilized when 2 outboards are required. This dual control adapter provides the user with steering and throttle on a single controller. The adapter slips easily onto both outboards and requires no special tools. Delivery and testing of the first outboard powerhead, delivered by Ricardo, failed to meet minimum requirements of power and submersibility. As a result, Option 2 was eliminated from further consideration. Option 3 was a commercial off-the-shelf based solution that resulted in the lowest life cycle cost. The downside was the military could not control new changes in manufacturing. The Raider engine can run on any mix of light and heavy-duty fuels, and switch between fuel types without interruption and requires no switch. The ECU is unique from other outboards as it provides the engine with a long-duration hot spark during initial startup that allows starting even with a wet spark plug. The ECU offers the capability to maintain the same RPM on 2 separate engines. The Raider engine also has a dewatering system. After opening the dewatering valve, a single pull of the starter cord purges the cylinders. After that, the engine starts reliably within 3 pulls of the cord. If it was left open, the dewatering valve automatically closes when the engine fires. The cowling and exterior profile of the Raider has been engineered to avoid possible snags and catch points when the engine is pulled up out of the water and onto the transom. The Raider has multiple inset handles for easy manipulation in the dark and in rough seas. The rugged design of the Raider withstands accidental dropping of the engine. It also has a narrow cross-section so that it can easily pass through submarine hatches. All new or modified parts on the TLDI outboard are coated using materials from our anti-corrosion program. Our studies and testing has shown we can treat starter motors to be submersible. This, combined with our rugged submersible batteries located underneath the cowling, provides the capability of electric start internally contained within the outboard. This option significantly reduces start time and fatigue to the soldier, especially in extreme cold weather and after submersion. On August 12th and 13th of 2013, 6 Raider engines, 4 rated at 50 horsepower and 2 rated at 40, were delivered to the Guardian Angels at Nellis Air Force Base. Day 1 of testing was spent giving an orientation of the function and operation of the motor, checking the weight, dimensions, and fit of the motor to the rubber inflatable boats, and developing a demonstration schedule for the following day. Day 2 consisted of multiple tests using 3 boats, 2 Zodiacs and 1 wing model. One of the Zodiacs and the wing were each fitted with a 50 horsepower Raider, and the second Zodiac was fitted with a 40 horsepower model. The first test of the day was submerging one of the remaining 50 horsepower engines and leaving it underwater while other testing was completed. Several test runs were performed to calculate time to plane and reach maximum speed using regular fuel. Demonstrations of maneuverability were also conducted to show how the rubber inflatable boats would react to the Raider engine. One of the test runs lasted 30 minutes and was used to demonstrate durability and to test fuel consumption. The fuel was then switched to JP8 and then to diesel, with the same series of testing being conducted on each fuel type. After this series of testing was completed, the 50 horsepower motor on the Zodiac was removed and replaced with the motor that had been submerged at the beginning of the day. The final test consisted of flipping the Zodiac twice to simulate potential rough sea conditions and restarting the Raider engine. Pre-production units of the Raider TLDI were built and have accumulated over 600 hours of on-water testing using JP5, JP8, diesel, and kerosene. Over 25 submersions at various depths have been completed with no major mechanical or electrical failures. Recent tests on 7 and 15 passenger inflatable boats using the Raider engine have demonstrated superior results against current military requirements. So if your requirements call for a rugged, militarized, multi-fuel submersible outboard motor, consider the Raider.